This is Algebra 1, Lesson 12, and we are going to return to the tortoise and hare, this time with a system of piecewise equations. We're also going to solve systems using substitution, using Math.new and GeoGebra. So this is a quick lesson. I have it scheduled for 1 day. So let's take a look at the Desmos activity. This is the return of the tortoise and hare. So in this activity, most of it came from a Desmos activity, tortoise and hare. So you may have seen it before, but I did change the end of it. So I wanted to show you what I've changed, and I have incorporated writing equations of piecewise functions. So the first is the classic tortoise and hare race, which we've already visited earlier in the year, so they probably already know what's happening and can easily answer this question. Hopefully this part does go quickly since they've seen this task in a different way earlier in the year if you did the lesson, the very first lesson, distant time graphs. Alright, and then here's some graphs, and they're supposed to label the graphs. I would definitely pace your student, and there are quite a few notes under teacher moves that you should read about because it'll give you some advice about how to question the students and things you might ask them to bring the conversation along. There's also sample responses. Alright, now see, now this is the labeled graph, which is why you need to pace because it's going to give them, reveal the answers on a later slide. So as you're going through, pace so they can go backward but not forward, and they'll tell the story about the fox now. So we've got the tortoise, the hare, and now a fox has joined the race. And here's all three, and then you can watch the actual race and how those fit the graph. Again, pace your students. You don't want them looking at the reveal until they've answered the questions. Alright, this is sort of a summary of the first part of the assignment. Can they read the graph? Can they interpret the graph? The slopes, the y-intercepts, and the solution. Well, maybe not the solution to the system because we're going to talk about that on a subsequent slide. Alright, so now we're going to break this down into parts. So we're going to start with the tortoise, and I just simply ask them to write an equation. It does say slope-intercept form, but technically any form is correct. The only thing is this is a self-checking item, and so for it to recognize it, it will need to be in slope-intercept form. The slope also should be as a fraction and not as a decimal. I believe it's a repeating decimal, so you wouldn't type that anyway. So just let them know it does need to be in a fraction form, simplified fraction. Alright, now this one, fortunately, the form is not as important. All correct forms will work, but what it will do is it will graph their function over this function, and it will turn blue basically. So if it's all blue, they know they got it, and if it's not, they'll see if it's right or not. You're also being asked to restrict the domains, so be sure that when they've typed their function in, that at the end, put the curly brackets and put in the domain for that piece. These are numbered 1 and 2, left to right. So they'll do the one from 0 to 6, and then they'll do the one that's after the 6-minute mark. This one also, it's kind of self-checking. Now, it doesn't check it in the dashboard, so for you, you'll have to look at their graphs, but the students will know if they are correct or not just by looking at what it's graphing. And the same for the hare. So they will do exactly the same thing. They will graph each piece. It will graph over. Let me just show you the first one to show you how cool this is. So it appears the slope for our first piece here is going to be 200, because if you go right 1, it's going up 2 marks, which would be 200. So if you put 200x in the blank, it's going to graph it in orange, but you see how the domain is not restricted. So if I restrict the domain, I would say 0 less than or equal to x less than or equal to, and let's see, I want it to stop at 6. And so they can instantly see that they've got that piece done because the orange is going to go over the black in the graph. So all three work that way, and then they'll need to submit it. And on the third piece, just to point this out, when you type this one in, this slope is kind of challenging. You'll notice there's no whole number integer coordinates here except for the one at the end of that line segment here. So for this piece, they're gonna have to estimate and just get it as close as they can. So I do give you the solution that I put in there for mine, but it can be different. As long as it's reasonably covering the black, then it's fine. We're getting back into systems of equations on screen 9, and we're looking for the solution to the system. So that's the point in the graph where the x and the y coordinates are the same for all three. So there is one point. What does that solution reveal in this context? So what is it telling you about the fox, the tortoise, and the hare, their time and their distance? So have them just put in words what that point reveals. And then on this one, they're going to create their own function. So we're going to leave these three there, the tortoise, the fox, and the hare, and we're going to add another function to this graph, and this is for a dog. So add a function d of x to the graph to represent a dog. Use the line tool to draw the graph, use the math input to write equations, and describe how his race compares to the others. So they can make it go faster, they can make the dog go slower. You could try to make him intersect this same point, but you don't have to. So there's really no limit here. They should describe his race in words, and they should put this in the box. This particular task is great for a portfolio because they are being creative. They're coming up with multiple representations for their function, so they'll have a graph and equation and words. And it really does test quite a few concepts, particularly if they choose to do a piecewise function. They would have to write multiple equations and put in this box down here. Remind them to use the math type, and to get the subscript with the 1, they just type _1 and it will automatically subscript the number for them when they type that in. That concludes our Desmos activity. As you can see, it's pretty rich. You could take more time on it, but I'm guessing the first half of the task will go fairly quickly, and the bulk of your time here will be spent on the last few screens. Let's go into the slides. The remainder of this lesson will be in their slides. The first thing I do is just give them a system and show it worked. So all they're doing is examining, looking at this, analyzing it, and typing some text here to explain what was substituted and why was it okay to do that substitution. Hopefully you can easily tell what was substituted because I did try to color code a little bit here to make it more obvious. These were the original two equations, and this is the work that was done to solve the system, and the solution is down at the bottom. So have them explain why it's okay to do the substitutions. Actually, I believe there's 3 times or twice there were substitutions in here. The next part of the task is going to math.new to solve a system using the substitution method. I have included a video on my website and for the kids in here in the slide that they can use to watch this being done. And basically they're going to do exactly that. They're going to go to math.new, they're going to type these 2 equations in, and they're going to solve the system. Part of this is learning the gestures so they can watch closely as I move things around on the screen. If you hover on the top left corner of an expression, they'll see a little box pop up and they can grab it and pull it around. So just watch that if they're having trouble. They can also just go back to math.new and start over if they've kind of wrecked their screen and don't want to try to fix it. So that's another option. Once they've created these 2 equations in math.new and basically duplicated what I've done in this video, they'll just put a screenshot here of their work. They will first need to type these equations, and then they will drag one y on top of the other and then solve the equation by clicking and dragging. So you'll notice as I'm clicking and dragging, it's just the same process as solving. Once they get the value for their x or their y, they'll drag that variable into the other, but I like to make a copy first. So that's what I'm doing here. I make a copy. Now notice I'll hover and see how it pops the little box up so I can pull it down. And now I'm going to take the X and substitute in for the X. And if you click there, it's going to combine those and you get the Y. So now they have the solution. Just click on text, type in this is the solution. And then I like to type the solution actually using the math type. And then I drag it again. See, I hover, there it is, and drag. And there it is. So they screen capture that and place that onto their slide. The next slide is the same process, but a different system. I made a very simple system for this one. They just take this Y and drag it up here to this Y, and it'll substitute in that too. And then they can solve it. So they are to insert a screenshot of their work on their slide when they're done. And then there's just one more like that. So they'll go to math.new, they'll type in these two equations, and they will substitute and they will solve. The last part of this activity or this lesson is to visit GeoGebra and solve a system on a whiteboard. So when you click here, it's going to take you out to a blank graph, and underneath the graph are two equations, and they're going to solve using substitution. So I will solve this system and show you what the work and the screenshot would look like for your students. And so this is what it would look like on your students' slides. They would put a picture of their work that they did on a whiteboard, and then they would put a copy of the graph with the solution marked at the website. And of course it will say correct. It also displays the two equations here. Be sure that they use different equations for each of their slides. There are 3 slides where they will do the same process. So this concludes our lesson on solving systems by substitution. Our next 2 lessons are kind of a mixture of lots of different concepts, and we do have our term exam coming up very soon. Y'all have a great day.